All right, hope everyone had a amazing break. Happy Thanksgiving to everyone. Okay, we're starting with evaluating sum and differences identities. So we talked about sum and difference identities a tiny bit before we left for break. I said we would worry about those more after break, and so here we go. All right, so let's go ahead and write these all out. Okay, and so it says sine of alpha. That's alpha plus beta. I just write it as little a and big B. Okay, and so it's going to look like this. So you're going to have sine of little a, cosine of big B, plus cosine of little a, sine of big B. Okay. Sine of a minus b, so difference formula for sine is going to be this. It's going to be sine of little a, cosine of big B minus cosine of little a, sine of big B. Okay. Cosine of a sum identity for cosine is going to be cosine of little a, cosine of big B minus sine of little a, sine of big B. So just notice the difference there, okay? And that's just how the identity is. It's not to trick you or anything, but it's just opposite of what's inside the parentheses for cosine with the sign here in the middle. So plus, minus, minus, that means, I think you know it's going to be plus, right? And so we're going to have cosine of little a, cosine of big B plus sine little a, sine of big B. Okay? Tangent, so tangent of A plus tangent of big B all over 1 minus tangent of A, tangent of big B. And then tan of A minus B is going to be tangent of A minus tangent of big B all over 1 plus tan A tangent of B. Okay, so I'm going to give you a second. Give you a second to write those down. Okay. Now, for these two sections here, we're looking at these practice problems. I would highly suggest having a filled out unit circle. Okay, so here's my filled out unit circle, right? And guys, I actually posted this for you back. I actually posted this for you on the Unit 4 tab. Okay, I would have that because it's going to help you. Okay, and then I would have a calculator as well. If you have a 36x, this does pretty much everything for you. Okay, if you don't, we're still going to go through it. You're going to have to do a couple of steps first, and then plug in. You have to do a couple more steps because the calculator just doesn't do as much for you. Okay, all right. So when we look at this, we look at these questions here, okay, what is it asking me? Well, it says find sine of 75, okay? Well, let's look at our unit circle and see if sine of 75 is there. If you notice, look what we have here. We have 0, 30, 45, 60, 90. 75 would fall somewhere in between 60 and 90. So back in the day, before calculators were invented, a mathematician said, well, hey, I know I can find the distinct angles that we use to create the unit circle, but what about ones in between? What if I have to build something at an angle of 89 degrees, or I have to build something at an angle of 2 degrees, or, just anything in between? So a mathematician came up with these sum and difference identities to be able to help us calculate what sine of 75 is. Okay? So what I'm going to do is I'm going to look either adding or subtracting for two angles on my unit circle that add up to equal 75. Okay? And so that is going to look like this. Okay? That is going to be sine of 30 degrees plus 45 degrees. Okay? Doesn't matter order-wise. Okay? You could also have done subtraction here by doing sine of 225 minus 150. Okay, those are all on the unit circle. Okay, you have multiple options. Okay, and so The nice thing is, well, the hard part is that yes, we have multiple options, but we all will get the same solution. Again, we are just evaluating here. We're just trying to find an answer. So then what that means is, okay, is that I just go in order here. Because the 30 is first, that means that's little a. Because the 45 is second, that means that that is big B. And so what I'm going to do is because I did 30 plus 45 and it's sign out front, I'm using this identity right here. And wherever there's a little a, I'm plugging in for 30. And wherever there's a big B, I'm plugging in for 45. And so it's going to look like this. Okay, it's going to be sine of 30 degrees, cosine of 45, because that's big B, plus cosine of little a, which we said was 30 degrees, sine of big B, which is 45 degrees. Okay, now, before you do this problem too, make sure your calculator, you turn it on in mode, it's in degrees, it's highlighted degrees, okay? And so I suggest the easy thing to do is you can just type in sine of 30 and it'll give you what it's equal to, all right? Or if you have your unit circle, which you will have a unit circle for the test on December 10th, you can go to say, okay, 30 degrees, what is sine equal to at 30? Because remember, sine is equal to the y values, cosine is equal to x, okay, 1/2. So since I know that sine of 30 degrees here is 1/2, I'm going to go ahead and replace that sine of 30 degrees with 1/2. I'm then going to look at cosine of 45. Well, I can type that in my calculator or look on the unit circle, and that gives me root 2 over 2. Plus, okay, don't forget your plus sign in between there. Now cosine of 30 degrees. So I can go on my unit circle and say, okay, cosine of 30 degrees, what is the x value? It's root 3 over 2. Or I suggest just type it into your calculator. Okay, sine of 45 degrees is going to be root 2 over 2, and there you go. So I just replace those all with what they are actually equal to, and now we're almost done. Now what we're going to do is we're going to plug this into our calculator here, this last part. Okay, and so it's going to look something like this. So you're going to go 1/2. And actually I like to do in parentheses just so it's easier. So 1/2, close parentheses, open parentheses, root 2 over 2, close parentheses, plus, open parentheses, fraction button, root 3 over 2, close parentheses, open parentheses, fraction button, root 2 over 2. Is that a 2 there? I don't think it is. Sorry, root 2 over 2, close parentheses, hit enter, and there you go. So we end up getting root 6 plus root 2 over 4, and I want the exact answer like that, no decimals. No decimals. So then my final answer would be root 6 plus root 2 over 4. And there you go. Okay? So number 2 now, we're doing cosine. It is radians. Since we are evaluating, guys, I think the easiest thing to do is to go from, just to have this into degrees. So the first thing I'm going to do is I'm going to go ahead and I'm going to multiply this by 180 over pi. And so when I do that, okay, 180 over pi times pi over 12 is 15. Okay? So now I have cosine of 15 degrees. Now, when you have a small number like this, I think really subtraction is the only option. You could do addition with negative angles. Okay? When I talk about negative angles, I talk about going clockwise, okay, clockwise instead of counterclockwise. We'll talk a little bit about that on Thursday in class and on the video. But ideally, I think best bet is to just do subtracting with positive angles. So the two angles I'm going to choose, and there's a lot of options here, okay? So if you choose a different option, you should get the same answer. It's 60 degrees minus 45 degrees. Again, that minus sign is part of the formula. That is a positive 45 degrees. Okay? That is not a negative 45. Okay? That minus sign is just for the formula. All right? So, again, what that means is, though, is that since 60 is first, that's going to be little a. 45 a second, that's going to be big B, and let's go ahead and let's write that out. So we're going to get cosine of little a, which is now 60 degrees, times cosine of big B, which is now 45. Not a negative 45. If I put a negative 45 in there, totally messes the whole problem up. Plus, because that's part of the identity, sine of little a, which is 60 degrees, sine of big B, which is 45 degrees. Okay? And so now that we've got that written out, let's go ahead now and let's plug that into our calculator and figure out what they're all equal to. Or looking at our unit circle. So cosine of 60 degrees, that's 1/2. Cosine of 45 degrees, that's root 2 over 2. Plus sine of 60 degrees. Again, I'm plugging this all into my calculator. I'm looking at the unit circle. I know I've repeated this a lot. Okay, we should know how to do this by now. We did this all in unit 1. That's root 3 over 2. And then sine of 45 is root 2 over 2. Okay, I already showed you how to plug this into your calculator. So I assume you should know how to do that by now. Go back to reference number 1 if you need to. And so when you plug that all into your calculator, if you did that correctly, you should get this. You should get root 2 plus root 6 over 4. And there you go. Okay, let's move on to example 3. So again, we're dealing with radians here. So the first thing I'm going to do is I'm going to multiply this by 180 over pi. Okay, and when I do that, negative 5 pi over 12 times 180 over pi, that's a negative 75 degrees. Okay, so the first time we've got a negative angle, and that is okay because we're still going to be able to use two positive angles to get that negative angle. Okay, so this time it's tangent. Okay, and so two angles on the unit circle that will subtract, and so when you have a negative angle, you are going to have to subtract unless if you want to add with two negative angles. Okay, if you do that, I would highly suggest having a calculator with you. Okay, so like if you wanted to do negative 30 plus negative 45, you could do that. It will give you negative 75, but I would suggest having the calculator because if you try to use the unit circle, it's going to be confusing. Okay, so I'm going to do positive 60 degrees minus a positive 135 degrees. So how do I know which identity to use? Well, I'm doing tangent on the outside, and I see that minus sign, so I'm using the difference identity. So again, we already know this, right? But little a is going to be 60. Big B is going to be 135 because big B comes second, little a comes first. Okay? So let's go ahead and let's fill it in. So we're going to get tangent of little a, which in this case is 60. And I don't know why I wrote TA, not all tangent. Sorry about that. So I've got tangent of 60 degrees minus tangent of big B, which is 135 degrees, all over 1 plus tangent of A, so 60 degrees, tangent of B, big B, 135. And now we're going to go the same route, right? We're going to go ahead and we're going to either look on our unit circle. Now, here's the deal. If you have a unit circle filled out, like this one here, which is the same one I posted in Unit 4 files, you need to go ahead at each one of these and find what tangent is. Because unfortunately, this is just cosine, sine, right? We don't have tangent. We would have to find those if we're going that method, okay? If you have access to a calculator, though, it's just really easy, right? We can just do the same thing. We can just go and say, on button, clear this, tangent, type in 60 degrees, make sure your calculator's in degrees, and there you go, right? So I'm going to go ahead and replace this formula with what they're equal to. So tangent of 60 degrees, that's root 3, minus, okay, tangent of 135 is actually negative 1. And so I put that in parentheses with another negative so that we understand here that we have a negative times a negative. All over 1 plus, parentheses here because we've got tangent of 60 multiplying tangent of 135. And so tangent of 60 we know is root 3. Tangent of 135, negative 1. Okay, and so let's see what happens after we plug that into our calculator. Guys, to do that by hand is very difficult. This is where you definitely need to have a calculator to calculate this. Okay, and again, your test on December 10th is going to be all multiple choice. So having a calculator would be very helpful. Okay, so we're going to go fraction button. We go second, square root, write root 3 in there. do a minus sign, not a negative sign. I almost did a negative sign there. Minus, open parentheses. Now this is where you will do a negative sign with that 1 there, not a minus sign. Okay, so it looks like that. All over 1 plus, parentheses, root 3. Sorry, I hit the wrong button there. Do not need that. I just need root 3. Scroll over, close parentheses, open parentheses, negative 1, close parentheses, and there we go. That looks exactly like what I've got written down on my sheet of paper there. Let's go ahead, let's hit enter. Okay, and we find out that tangent of negative 75 degrees is equal to a negative root 3 minus 2. Okay, last example on this section here. Okay, this time it's in degrees, so we don't have to worry about changing it to radians or anything. Okay, it's tangent again. So this time, because it's a big angle, 195, I'm going to go ahead and I'm going to use the sum identity for tangent, and I'm going to use these two angles. I'm going to go 60 degrees actually, plus 135 degrees. So again, little a, big B. Again, what am I doing? I'm finding two angles on the unit circle. 60, 135. All these angles come from what is on our unit circle filled out. I'm not taking an angle that is not on the unit circle. And so now let's go ahead, because it's a plus, we're using this sum identity for tangent, and let's fill that out. Okay? So it's going to look like this. So we're going to get tangent of 60 degrees, okay, plus tangent of 135 degrees over 1 minus tangent of 60 degrees, tangent of 135. And so there we go. So we used my identity to fill that out. And now what I'm going to do is I'm going to go ahead and I'm going to fill out those values, what they're equal to. So tangent is 60 degrees. Okay, tangent 60 degrees, that's equal to root 3. Okay. Well, we kind of already know because we did this in the last problem. So I'm just going to go quick here. So plus, I just put a negative 1 there in the parentheses. And then I do 1 minus parentheses root 3 times tangent of 135, which is also negative 1. Okay, I just showed how to put this into my calculator, okay, on number 3. So refer back to that if you have any issues. And so if you put this into your calculator correctly, this is what you should have got. Negative root 3 plus 2. Okay, so that's us finding a non-angle on the unit circle using the sum and difference identities. Okay, now what we're going to do in this next section here, okay, is we're going to be doing the same thing, but we're going to have to do a kind of a little bit more here because we're not going to be given enough information. Okay? So if you recall back in Unit 1, we talked about drawing right triangles and using right triangle trig, okay, to help us solve for sine, cosine, and tangent. And so the first thing I always said to you is that we restricted the domain. Now in the same case here, we're restricting the domain because these answers fall in multiple domains, okay? And I need to know exactly what quadrant my triangle's in to draw, okay? And I'll explain why we need to draw a triangle here in a second. So when we look at this beginning here, we see 0 to pi over 2 for little a, we see 0 to pi over 2 for big B, and so that means then that both little a and big B are falling in quadrant 1. So therefore, I'm going to draw triangles here in quadrant 1. So the first thing I want to do is see what it's asking me. For example, if it says, hey, take sine of little a plus big B. Okay, find it. We're trying to evaluate for it. And it's actually giving me a tiny bit of information. So let's see what information that is. So first thing I want to do is I'm going to go ahead and I'm going to write out my identity there. So recall sine a plus b is sine a, cosine big B plus cosine of little a, sine of big B. And what you'll come to notice is that now I've been given 2 out of the 4 parts of this identity. So on our next step, let's go ahead and let's replace those. So cosine of little a is 4/5. Sine of big B is 12/37. But the problem is I'm missing two parts. Okay? And I haven't been given any other information than besides I know it's in quadrant 1 and I know cosine of little a and sine of big B. So what I have to do then is I have to do something that I should recall from Unit 1. I have to draw a triangle in quadrant 1, label it based on what I know, okay, from what was given to me, and then I'm going to go and have to find sine of little a and then cosine of big B. So what does that mean? So quadrant 1 triangle here, right? Okay. So how do we draw a triangle in quadrant 1? We start at the origin. How do we get to quadrant 1? We go right, and then we go up. Connect those points. I put little a down there because that's where the origin was. That's where I started at, right angle here. And now how do we know how to label this triangle? Well, we know because of some of the information given to us. So cosine, right? So cosine. So recall with right triangle trig, cosine was equal to adjacent over hypotenuse. So the 4 is my adjacent side. Hypotenuse is my denominator, which is 5 in this case. Okay? So now you've got 2 out of the 3 sides. You can find that third side by either doing Pythagorean theorem, okay, because it's the right triangle. But I think it's very important that you remember your Pythagorean triples. 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25. Memorize those. You can write those on your formula sheet for the test next week. Okay. So for time purposes, that is going to be a 3 because this is a Pythagorean triple, 3, 4, 5. And so now the only thing left for me to do is find sine of little a. And so recall, sine of little a, what is sine equal to? Opposite over hypotenuse. And so that means then sine of little a, my opposite side from a is 3, my hypotenuse is 5. And so I'm going to directly go right in here now. And I'm going to fill in sine of little a is now 3/5. Now, same thing for big B. Okay, same thing for big B. Let's draw that triangle. Okay, let's draw that triangle in quadrant 1. So how do we get to quadrant 1 again? We go right and then up. Connect, right triangle here. And now this time, this one's a little bit bigger fraction here. Sine of B. So remember, sine, what is sine equal to? That's opposite over hypotenuse. Just talk to it. So my opposite is 12. My hypotenuse is 37. Again, for time purposes, this is a Pythagorean triple. This missing side is going to be 35. And so now what we need to do is we need to find cosine of big B, which remember, cosine is equal to adjacent over hypotenuse. And so based on this triangle here, my adjacent side is going to be 35. My hypotenuse is going to be 37. And so where I see this cosine B here, I'm going to go ahead and replace it with a 35 over 37. And there you go. Now we have enough information to evaluate to find what sine of A plus B is equal to, or big B. And so we're just going to go ahead and type that into our calculator. And if you did that correctly, you should have gotten 153 over 185. Okay. So then last but not least here, I'm going to kind of speed this one up because we just did a problem like this. Okay, so first thing I want to write out is I'm going to write out the difference formula for cosine. So it's going to be cosine of A, cosine of big B, plus sine of little a, sine of big B. Okay, now let's go ahead and let's fill out what was given to me. So I know cosine of little a, so 7 over 25. And I know cosine of big B, which is 3 over 5. But I'm still missing sine of little a and sine of little b. So what we have to do then again is we look at our restrictions, which is in quadrant 1 for both of these. So we're going to go ahead here for little a. We're going to draw our right triangle here. Again, how do we get to quadrant 1? Go right and up. And then we're going to draw a little a down there. And now we're going to fill it out based on what has been given to me. So I know cosine of little a to be 7 over 25. Cosine is equal to adjacent over hypotenuse. That's why I was able to label the 7 because that's my adjacent side. My hypotenuse 25 because that's my hypotenuse. Remember, hypotenuse is always opposite the right angle. Adjacent is always closest to the angle. That's not the hypotenuse. For time purposes, this is a Pythagorean triple. I just said it, 7, 24, 25. So the opposite side is 24. And so what I'm going to do now is I'm going to find sine of little a, which is opposite over hypotenuse. And so opposite over hypotenuse is going to be 24 over 25. And so where there's a sine of little a there, I'm going to replace it now with 24 over 25. Okay? For b here, big B, I hope you guys can see this. I think so. Maybe not really. I'll scroll up a little bit, sorry. So for big B, again, draw that triangle. We're in quadrant 1 for both because of the parameters right here. And now what does it tell you? I know cosine of big B. And so again, cosine is adjacent hypotenuse. So adjacent for 3, hypotenuse for 5. This opposite side here is going to be 4. Okay? Because of a Pythagorean triple. And now sine of big B is equal to opposite over hypotenuse. So opposite 4, hypotenuse 5. Okay? And now since I know what sine of big B is, I'm going to replace that sine of big B with that 4/5. And now I have enough information to solve. Okay? And so all I'm going to do now is I'm going to take this step right here and I'm going to plug it into the calculator. We've already seen how to do that back all the way to number 1. So if you're not sure how to do that, refer back to that. And when I do that, if you did that correctly, you should have gotten 117 over 125. Okay? So that is a lot, but like I said, I wanted to make sure I get the video up for this. So if you have any questions, you can refer back to that. All right. Thanks, guys, and I will talk to you tomorrow in class. Have a great day.